a curious carbon finding on Mars, and the prospect of pirates in space. You're listening to Are We There Yet?, the radio show exploring space exploration. Hi, I'm Brendan Byrne. One of our rover friends on Mars made a big discovery on the red planet: big old carbon molecules. They're organic, suggesting they could be from ancient times and possibly linked to life on the planet. But extraordinary claims need extraordinary evidence. For that, we'll speak with University of Florida's Amy Williams about this organic carbon on Mars and if it could lead scientists closer to answering the age-old question: could there have been life on Mars? Then, just like pirates roam the seas, the idea of pirates or criminals in space could be more of a reality than science fiction. Space Piracy, Preparing for a Criminal Crisis in Orbit, explores that as humans commercialize and potentially live in space in the future, crime in orbit could be a real possibility. We'll speak with the book's authors, Hugh Taylor and Mark Feldman, about potential raiders in orbit. That's ahead on Are We There Yet? Could Mars have been more habitable in ancient times? In a recent discovery, the Curiosity rover helped find the largest organic compounds ever found on the red planet, including organic carbon. Organic carbon is a building block element here on Earth, and while it could point to signs of life on the red planet, organic carbon can be made in other non-biological ways. Here to talk more about the discovery is Amy Williams, a member of the rover's science teams and an astrobiologist at the University of Florida. Amy, welcome back to the show. We've got some really exciting things to talk about, including a finding by NASA's Curiosity rover, which is this mega organic molecule. Tell us why this is so exciting.
So if you get to listen to me rant on about organic carbon all the time on this show, you'll know that I'm going to be super excited about this. What the paper describes is discovering a handful, I would say 3, molecules that are sort of the largest that we've been able to detect so far with the SAM instrument on board Curiosity.
And what does that mean?
We know that there's organic carbon on Mars, and it's being delivered by meteorites to the surface all the time, but then we also expect that on the surface to be degraded. So seeing something that's as large as these molecules, so these are hydrocarbons, so they're chains of carbons connected to each other, and we have one chain that has 10 carbons, one that has 11, and one that has 12. And so things this big, it's really, you would expect them to be broken down by the radiation environment. So the fact that we drilled these out from the subsurface is one indication that they are probably preserved from an older time on Mars. And it also took sort of this special experiment that we ran to be able to detect these molecules. A couple of the stars had to align for this detection to occur, but the base interest here is, it's larger and larger molecules like these that could feed into potentially an origin of life on Mars. It, can represent the types of molecules we might look for if we want to look for evidence of former life on Mars. So that's where the really exciting, why does this matter to us part come into play. It's showing us things that we've never seen on Mars before that could actually tell you more about whether life ever arose on Mars.
You said they could be preserved because these tend to be broken down by the radiation. Is there also a hypothesis that they could be newer, or are there any other alternative explanations to why they have maintained their consistency for so long?
Yeah, it's really challenging. Obviously, we don't keep track of every impact that Mars has experienced. And, especially, we collected this sample years ago now, actually. And it was one of the samples that was sitting inside the belly of the rover, and we were able to perform an experiment on it after sampling it. So tend to lean away from it being sort of brand new, because you would imagine that we would have recognized that we were sampling in a little crater, as opposed to the lake bed, the very ancient dried out lake bed that we did sample down at the base of Mount Sharp and Gale Crater.
So if that is the case, that it is a preserved sample, then this gives a little more credence to the fact that this could be a sign of ancient biology, right?
Well, all right. So then I'll make you step back a little bit. Again, you also know, as an astrobiologist, I'm going to tell you, let's take the most responsible route to describing these things. So, these types of molecules, these are just straight chains of carbons called alkanes. You can make these abiotically without life. You can make them on meteorites. What makes this really intriguing is that when we performed experiments in the lab to see how you get these molecules to basically that come out into the instrument the way that we see them on Mars, you actually put in a molecule called a fatty acid. And a change in that molecule, it takes a piece off of it, allows us to see these straight carbon chain alkanes that I described to you that we see in the study. This gets really tricky because those fatty acids or carboxylic acids, they're the same thing. Gosh, life does tend to make them sort of right at the edge of the length range of these molecules that we see on Mars. And so once again, Mars has made it so hard to say anything super conclusive. It just keeps giving us these so tantalizing answers and saying, well, maybe this and maybe that. So, again, we need to be responsible and careful about what we report, right? So these are not evidence for life in and of themselves. The molecules they come from it's really interesting to see something this large that's not made by life. So that's where we all are pretty intrigued by whether, could these come from biologic or abiotic sources.
And as you have said, always on the show, extraordinary claims require extraordinary evidence. So that is what you're looking for, right?
That's exactly right.
One thing that was really intriguing to me is that you said you performed an experiment in the lab to see if you could explain what you were seeing on Mars. Is that a common practice in astrobiology?
Oh, absolutely. You want to try to replicate your experimental results. I would say that's, of course, across science. And so, many instruments that we send to space have what we call engineering models back on Earth, ways that we can run these kinds of experiments, do tests, and do way more rigorous studies of, we think it's X, Y, or Z molecule, so we can perform tens, hundreds of experiments on Earth to help refine that when you don't have the power or the resources or what have you to perform those same experiments in flight. So this is pretty common, and we do this a lot with the engineering models of the SAM instrument here on Earth.
And when you mentioned experiments performed, were there also experiments performed on this sample on Curiosity as well? Or was it just you're kind of looking at these older samples that you had found?
The cool thing about this sample and where it comes from, it's this ancient link bed. It's part of the suite of samples where we've seen organic molecules preserved before. So, you say, could it be new and new organics? And I can say, based on all the other studies we have, we think this, really is preserved in this kind of lowest layer of Gale crater that we were able to explore when we first landed. We collected this sample many years ago, and we've been carrying it around. We call it a doggy bag, which always tickled me that you might be carrying a little lunch bag around with something to snack on later.
A leftover box, yeah.
Yeah, that's basically what SAM has done. And so because one of the chemicals inside of the SAM instrument actually had a little leak in it, and we knew about this from the very beginning when we landed on Mars and started turning on the instruments. And so what might have been an oops actually turned into a unique advantage. We call this opportunistic derivatization. So this is, basically
happy accident.
Yeah, happy accident. It allows us to perform an experiment normally you would only be able to do by delivering the sample to a cup and making it happen right then and there. And we basically let the sample react with sort of the vapor from this chemical. And so it performed the experiment without us even purposefully conducting it. And that's how we get these organics that we haven't seen before that are so large by performing this kind of experiment. So in some ways, like I was saying, the Martian stars had to align for this to work out. But I think it's just one more example of the serendipity that does sometimes play a role in discovery. Let's
take one more big step back on this. You're excited that this is carbon, a particularly unique carbon molecule or molecules. Why carbon? That's the age-old question I get all the time. Why are astrobiologists like yourself looking specifically for carbon?
We're so obsessed with carbon, aren't we? And it's not just carbon necessarily, but in my case, organic carbon. So yeah, go ahead as a listener and look at your hands and think about every cell inside of your body. All of that is made up of organic carbon. All life on Earth as we know it, everything that is and once was and will be, is made of organic carbon. And so we know that the original building blocks for life, you can find those on meteorites made in the interstellar medium. And it's seeing these fragments, these little bits and pieces on other worlds really starts to fill in the puzzle of, how are these organics or how are these molecules delivered to worlds? And how was that transition from just chemistry to biology? How did that eventually occur? So seeing organic carbon on Mars is great because it might be evidence for something preserved. It might just be evidence for the building blocks for life preserved in these rocks over billions of years. And that at least gives us some sense for, how frequently might origins of life occur on planets, in our galaxy. It might be relatively frequent. We won't really know until we discover that other life. But this is why, I keep talking about organic carbon. It's the building block for all life as we know it. So it's a really great way to start your search for life beyond Earth.
From chemistry to biology. I love that. Amy, finally, I want to chat with you a bit about the future of NASA funding in a draft budget proposal from the White House for the future of NASA's budget. There are significant cuts to particularly science programs. What would this mean for the research projects that you're working on and your rover buddies' Perseverance and Curiosity?
So I'll just preface by saying that right now, the budget that's come out of the White House has between 70 and 30% cuts to science fields relevant to NASA. So astrophysics has a 70% cut in their budget, heliophysics, planetary science, earth science. So planetary science is kind of looking at a 30% cut, and that would mean cutting out Mars sample return, which if you've heard me talk about Perseverance and the awesome discoveries that rover has made, that would basically say we're not going to return those extraordinary samples to Earth. It has cuts for several missions that are in their extended mission profiles at this point, but still returning really powerful science. And there are, of course, other cuts, not launching the Roman Space Telescope, not continuing Artemis past Artemis 3. So, all of the vision for being, we like to talk about being leaders in science and technology in the U.S. I've always seen this as a really international collaboration, right? This is for humanity. It's not just one person or one group of people. But if you want us to keep kind of pushing the boundaries of science and technology, if you want the next Velcro to be developed, then you have to spend money on science and technology. And I would describe these cuts as apocalyptic. It's going to shut down so much of what all of us are doing, potentially my research, those of my colleagues, those of people I don't even agree with their science, but they're doing important things as well. And so it's really jarring, and it's a really scary time for science to be able to move forward. And so I would say, what I've been doing is actually reaching out to my elected representatives and letting them know how these kinds of cuts would impact me, my students, the future workforce of Florida and our nation, and trying to make it clear that this would be devastating. And I want to stand up and say that we need to fund science.
And it seems that you and your teams and your colleagues are on the cusp of something so incredible on the surface of Mars. But as you mentioned, we need to have that extraordinary evidence to come back, and it seems like that is in jeopardy with these budget cuts, right?
Yeah, I would agree with that.
We've been speaking with Amy Williams. She is an astrobiologist at the University of Florida and member of NASA's science teams on the Perseverance and Curiosity rovers. Amy, thanks for joining us.
Thank you, Brendan.
Still to come, pirates roam the seas, but what about space?
This is a problem that doesn't really exist yet, although you could argue that we're in the very early stages of it. Science fiction is seductive because it's like, okay, it's fantastic, it's amazing, who knows, it'll never happen, it could be 1,000 years from now. But the reality is this problem is creeping up on us, and our basic premise is that now is the time to be thinking about it.
That's just ahead on Are We There Yet? You're listening to Are We There Yet? I'm Brendan Byrne. We know black holes exist in our universe, consuming just about anything in its path and only getting bigger as they swallow whatever is nearby. But there are other things that engulf asteroids, nearby rocky surfaces, and even planets. That would be a star in our own galaxy. With the help from NASA's James Webb Space Telescope, a new paper suggests a planet crept towards its own star before being swallowed whole. Are stars more like black holes, and could ours be one? We'll talk about this next week on Are We There Yet? But for now, we're talking about crime in orbit. In science fiction, movies and shows like Star Wars and Star Trek, one popular theme is the idea that criminals roam the galaxy. While these characters aren't real, could criminals prowl our solar system one day? In the new book, Space Piracy, Preparing for a Criminal Crisis in Orbit, that possibility is explored, along with a look at the current laws that are in place to monitor crime off-planet. They're from the Center of Space Crime, Piracy, and Governments. Mark Feldman is the executive director, and Hugh Taylor is a director. Hugh and Mark, welcome to the show.
Thank you. We're glad to be here.
Thanks for having us.
Hey, so the book opens comparing Star Wars to our space world now. I am a huge Star Wars fan, so I appreciate that. But Mark, I'm going to start with you. Why did you choose that scene to set the stage for the thesis of this book?
Well, it did have, if I remember that, with nefarious characters in the movie. And while it may have been exaggerated, it is our take on the thesis of the book that there will be some extraordinarily nefarious, nasty, and rather evil characters that will be inhabiting space, if not now, in the not too distant future, as pirates and as criminals become aware of the potential of profits and plunder in space. And we thought that that was a good scene to basically open up that book, get the readers involved in our thesis, which is quite simply that non-state actors, criminals, cartels, pirates, will be deeply involved in inhabiting space, not just sovereign nations.
Hugh, what is the argument that we shouldn't be thinking of this as science fiction at this point and be thinking of it as a very short-term science fact?
It's been a little bit challenging because this is a problem that doesn't really exist yet, although you could argue that we're in the very early stages of it. The science fiction is seductive because it's like, okay, it's fantastic, it's amazing, it's who knows, it'll never happen, it could be 1,000 years from now. But the reality is this problem is creeping up on us, and our basic premise is that now is the time to be thinking about it. My point in the book is that we now spend $250 billion a year fighting, cyber threats because of bad decisions in engineering that were made 60 years ago around computer architecture. And if we want to avoid that kind of situation in space, this is the time to be thinking about it and treat this, as you said, as a fact or a soon-to-be fact.
We call it speculative nonfiction.
Ooh, I like that.
It's sort of a touching point to science fiction. Science fiction has a very weird history, and we mention it in the book of a movie that was actually quite popular in Germany, a silent movie called Women on the Moon. That's the English translation of the German. And the story, essentially, it's a bit of a romp of a bunch of characters looking for treasure on the moon. Sounds sort of like plunder in space and the commercialization of it. But what was fascinating is that movie, which was, again, a phenomenon quite popular in Germany, had a couple of very interesting people that watched it. The first and most notable one was Wernher von Braun, and the second one was a gentleman by the name Hans Oberith, and the two of them together were responsible for really space and V2s and all the way into our space program in the United States when we brought them from Germany after the war. What was predictive about it is that when von Braun got his seed money from the German military in the mid-30s, it didn't take long for the military to censor the movie, refuse to have anybody see it. Not because they had a problem with ideological component of the movie, but because designs and the rocketry and everything about what they were doing in the development of German rocketry had a very eerie connection and similarities based on the art direction of the movie. And that was actually, it was stunning if you look at early pictures of from the film and what they were doing at that time. It was breathtakingly almost identical.
I'm thinking to agreements that are already in place that one would think would help prepare for this new world. I'm thinking of the Outer Space Treaty and other things. Are there foundational laws or documents or treaties in place today that can help prevent this? Or do we really need to rethink pretty much all of our space diplomacy efforts at this point?
The treaties are a good foundation and they are applicable, but there's a lot of white space that needs to be filled in and a lot of ambiguity around how laws might be enforced. Keep in mind that when we talk about space piracy, we're contemplating activities, a lot of which could be happening on the ground, like hijacking of space equipment. And you immediately run into some of the deficiencies of international law, which have come up, fighting piracy at sea. And so in space, it's even more complicated. And the treaties are helpful and not helpful in the sense that you can't really establish international sovereignty in space. So there's a lot of ambiguity about which laws would apply and who would enforce them if they could be enforced. I mean, we're in an environment in space where if you have a commercial venture in space and somebody, steals from you, even if it's against the law, who's going to stop them? And that's a real problem in practical terms.
You mean to tell me criminals don't care about the 1967 Outer Space Treaty and will follow it? Hugh, you kind of alluded to this, but some of the issues, you can compare this to, issues in governing international waters. It seems to be the issue is there are no boundaries in space, and there will not be, right?
Well, it's unclear. My understanding of space law, which is very complicated, and we're not lawyers, is that, it's illegal, according to the treaty, for the United States or Russia to say that a piece of the moon, for example, is their territory. If the United States builds a lunar outpost, that outpost is considered part of the United States according to the law. So if somebody commits a crime in that place, they're subject to American law, at least in theory. So it gets a little complicated, but this is a case where the practicalities of law enforcement are very significant. As Mark just mentioned, like, for example, you go back to the Caribbean in the 1700s, that was about as remote as space is now. So people could do more or less whatever they wanted. It took months for anybody to catch up with them if they ever did. And space may present a similar type of venue. And on Earth, like, this is something that the book really revealed, is that the way the world really works versus the way people think it works is often quite different. Especially a lot of space operations are conducted in equatorial countries that may not have the same levels of government infrastructure and law enforcement and laws that you have like in UK, in the EU or United States. And so you might have, for example, local criminal groups that are really running the thing where you're launching your rockets and where your ground stations are. And you're going to have to deal with them. It's not the official government of that country may not be that helpful to you.
It would be analogous, if I can say that, for instance, if, let's say, take Guinea-Bissau. Mexican cartel, Sinaloa, runs the oil business there. It first started off as they were using Guinea-Bissau in Africa as a transport between Latin America, Africa, and Europe. But because the Sinaloa cartel had experience in working with Pemex and extorting from it, they saw easy pickings. So back to Mexico, the cartels have a great deal of control over the airport operations. It's not out of the realm of possibilities that with spaceports in countries outside the United States, cartels will basically have control of the access to the spaceports, what's in the spaceports, and develop spaceports on their own.
With the caveat that I know that this is speculative, what other types of crime are we looking at? Like when we talk about space hacking or space hijacking, is it these bad faith actors taking control of a satellite and doing nefarious things, or taking control of a satellite and holding it at ransom, much like folks do down here for ransomware attacks? What does the future of space crime look like?
So I think in the near term, it could be things like hijacking of satellites or theft of space equipment, ransoming space equipment or space cargoes. I think as you get further out in the future, you could be looking at more, disruption or hijacking of space products and space industry. Which is something that doesn't really exist yet, but people are, for example, if they're mining on the moon or mining on an asteroid, the transport of those materials could be hijacked by pirates. There's also potential for financial crime in space, like money laundering and fraud, as well as smuggling, which is something we talk about in the book, which isn't really piracy per se, but it's kind of adjacent. The other thing which we wanted to emphasize is the use of piracy for geopolitical reasons. This is something that happened in the old days, and it's happening now in cyber world, where a country will encourage a local cyber gang to disrupt the operations of its adversary, but say, hey, it wasn't us. We didn't do anything. It's these criminals, wink, wink. And this is what happened, between England and Spain in the 1700s. It could happen now where a criminal gang operating by behalf of China could, blow up an American satellite, and the Chinese government could say, well, don't look at us. Wasn't us, deniability.
Our assumption that criminals will have the technological means, even possibly even more advanced, because historically, criminals tend to be extremely innovative. They have the financial means to do so. So, historical example, although it is a bit of an analogy, is during the colonial times in the United States, pirates and privateers were the impetus of advancing shipbuilding technology and design all the way from colonial shipbuilding centers from Massachusetts all the way down to the Carolinas, because their needs, the shipbuilders were building merchant ships, but the needs of privateers and pirates were basically fast, lethal, slim, get the plunder, get a couple of people to ransom and move on. We see the same thing happening on a more sophisticated level in technological development of creating rockets that are very fast, unlike the lumbering ones. We see the technological developments in the utilization of AI materials, because they will involve themselves in the investments in venture capital companies or create their own to develop these things clandestinely. And then nobody will know about it until they are revealed in criminal activities.
Finally, Hugh and Mark, what are you hoping nations will take away from this, as you call it, speculative nonfiction, as to what could be happening in the very near future when it comes to space crime? What action do you want to happen now?
We think that at least two things should happen. One is some sort of dialogue between a lot of diverse stakeholders to talk about addressing this problem through secure design principles. And then also, trying to set some standards for security and criminal mitigation in space. And the model would be aviation, where currently, for example, you can't put a plane in the air without certain certifications of the equipment, the avionics and stuff, that the same should hold for space as well to fight crime.
It's also, I would like to say, they need to understand that there are and will be non-state actors as deeply involved in space on all levels. Ground, in space, they will have the intelligence, they will have the finance, they will have the technological abilities, they will be lethal, they will forge alliances clandestinely with no doubt clandestine intelligence agencies, as you alluded to, as plausible deniabilities in sort of right threshold, but not exactly warfare.
A terrifying future. Thanks for laying it out. We've been speaking with Mark Feldman and Hugh Taylor. They are the authors of Space Piracy, Preparing for a Criminal Crisis in Orbit. Mark, Hugh, thank you so much for joining us.
Well, thank you for having us.
Mark Feldman is the executive director, and Hugh Taylor is the director of the Center of Space Crime, Piracy, and Governance. That's going to do it for this week's show. If you're not already, be sure to subscribe to the show's podcast feed so you never miss an episode. Do that on the Central Florida Public Media app, the NPR app, Apple Podcasts, Spotify, YouTube, really wherever you get your podcasts. Stay connected with the show. Follow us on social media. Our handles on Instagram and Facebook are at AWTYSpace. And if you got an idea for a future episode of the show, or you'd like to join us as a guest, reach out. Our email is arewetheryet@cfpublic.org. More space coverage online, cfpublic.org/space. Are We There is a production of Central Florida Public Media. Our producer is Marion Summerall. Our intern is Allison Castillo. Editorial guidance from Latoya Dennis. Support for Are We There Yet comes from our listeners. Until next week, I'm Brendan Byrne. Thanks for listening.